What comes to mind when you hear coin? For most people, it's Bitcoin or investment talk. Many see blockchain as just the technology behind Bitcoin, or simply a way to transfer and record digital assets. But if you look closer, you'll see blockchain can be used in much more diverse ways. For example, someone can receive their salary distributed every second through blockchain. Another can publish music and earn revenue without intermediaries. And someone else can simply post on social media and turn that activity itself into income. These services aren't just about sending and receiving coins. They are built on blockchain apps, where contracts are processed based on predefined conditions. At the core are smart contracts and the EVM, the Ethereum virtual machine, which interprets and executes them. In this video, we'll explain how blockchain runs and records contracts, and how the EVM makes it possible. Ethereum is a distributed network where computers around the world store and verify data together. These computers are called nodes. Each node processes the same data in the same way and compares the results. A process called consensus, where only if multiple nodes agree on the outcome is it recorded on the blockchain. This method of comparing and verifying results, without a central server, is called a decentralized consensus structure. Thanks to this structure, data can't be altered arbitrarily, and records can be trusted through majority verification. It's easier to understand this structure if you think of older P2P networks like torrents. In blockchain, even if someone claims I received tokens, if most nodes say no such transaction exists, it will not be recorded. Conversely, only if the majority of nodes agree this transaction did happen, will it be recorded on the blockchain. Blockchain goes beyond just storing data. The network checks if conditions are met and then processes the contract. This is called a smart contract. A smart contract isn't a written document, but a program made of code, a digital promise that runs when specific conditions are satisfied. For example, you can create a smart contract with the condition: if A sends 1 ETH, then B receives 100 tokens. The nodes verify whether this condition is met, and if the majority agree, the contract is executed. And the result, transaction, is recorded on the blockchain. The key point is that there is no central authority to approve or process it. These smart contracts are already used in real services. For example, Sablier is a service that lets you receive your salary split into time intervals instead of all at once. In the smart contract, conditions like when and how much are predefined, and once those conditions are met, it transfers the specified amount. Another example is Capsule NFT, a digital time capsule NFT that can only be opened at a set time. Nodes check the preset time and allow access to the NFT's contents only when the condition is met. Smart contracts are a new type of contract system, where trust is built not by one person or institution, but by the entire network. Smart contracts are not sufficient with conditions alone. They require an executor that reads, processes, and produces results. Ethereum has such an executor, the EVM, or Ethereum virtual machine. Bitcoin also has an executor called BVM, but it can only handle simple transfers like who sent how much, and is not suitable for complex conditions or flows. By analogy, Bitcoin is like a calculator limited to basic operations, while Ethereum is like a computer capable of running many programs. Thanks to the EVM, Ethereum can create and execute complex contracts, and has grown beyond simple transfers into a platform for running decentralized apps. The EVM reads and executes smart contracts, and now we'll see how they are processed and recorded on the blockchain. When a smart contract runs, multiple nodes use the EVM with the same code and inputs, always producing the same result. The inputs and the result are then recorded in a transaction. Because anyone can rerun these steps on the EVM and get the same result. The transaction can be trusted without intermediaries. But the transaction is not stored in a block immediately. It must go through network-wide consensus before being stored in a block. This consensus works by comparing transactions across nodes and recording only when the majority agrees. Thanks to this structure, many decentralized apps can run on Ethereum. For example, Uniswap is a decentralized exchange where, when a user connects their wallet and clicks a button, that action triggers a smart contract executed by the EVM and recorded on the blockchain after majority consensus. Another example is Lens Protocol, where actions like posting or following trigger smart contracts, enabling users to own their content without a central server. The consensus process is where multiple nodes execute the contract in the same way, verify the transactions, and only if the majority agrees is it recorded on the blockchain. Conversely, if the majority of nodes do not agree on the result, that block is rejected and discarded. Why is this consensus process necessary? Because blockchain has no central server or administrator. For an action to be trusted, all participants must confirm the same result, and only with majority verification. An agreement can it be recorded. Through this process, blockchain reliably stores information on who did what and when, with records processed in blocks based on time or transaction count. In the end, consensus is not about someone deciding the answer, but a system that verifies whether the majority agrees on the result. If one node creates a manipulated block, it won't be accepted without agreement from other nodes. Manipulation is difficult because thousands of nodes worldwide independently verify transactions, and succeeding would require controlling the entire network. Thanks to this structural feature, blockchain is designed in a way that makes manipulation extremely difficult. Ethereum runs apps through EVM execution and consensus, enabling decentralization, but also creating some technical limitations. To understand these issues, we need the scalability trilemma. The idea that scalability, security, and decentralization are hard to achieve together. Imagine a triangle. Each corner represents scalability, security, and decentralization. Ethereum prioritized decentralization and security, which naturally limited speed and fees. The first limitation is processing speed. As all nodes must execute the smart contract the same way and compare transactions. Transactions aren't recorded immediately, but must pass network-wide consensus, which ensures reliability but slows processing. Especially since Ethereum limits the number of transactions per block. Higher volume means longer wait times. Why not just increase the block size? It's possible, but larger blocks demand more resources, making participation harder for some nodes. Furthermore, larger blocks slow down their transmission across the globe, potentially negatively impacting consensus and security. Strengthening either scalability, security, or decentralization at the expense of the others is the core of the scalability trilemma. The second limitation is how fees work. The EVM is not just storage, but a complex executor that interprets and computes contract conditions. Running these contracts costs money. The more steps a contract takes, the higher the fee for that transaction. This pricing helps keep the network from getting clogged. But it also means Ethereum can't offer the raw computing power of modern personal computers. The third limitation is privacy, as all Ethereum transactions are public on the blockchain. For example, anyone can see a wallet's contracts and transactions. like having your personal ledger exposed online in real time. This structure is strong in trust and transparency, but weak in privacy, which requires extra cryptography and may increase time and costs. Then why did Ethereum choose this structure? Since Bitcoin's BVM handled only simple transfers, Ethereum built a general-purpose environment for apps to run. To let users create and run contracts, Ethereum accepted complexity for flexibility, with the EVM at its core. These issues stem from Ethereum's overall structure, so balanced design. And complementary technologies matter more than a single fix. We've explored Ethereum and the EVM. At its core, the EVM runs smart contracts across nodes and records transactions through consensus. Beyond simple transfers, this structure makes Ethereum a decentralized platform, where apps can run securely without a central server. However, this structure has limits such as slow speed, high fees, and privacy concerns. These issues aren't just from the EVM, but from Ethereum's trade-offs in choosing decentralization and security over scalability. To address these limits, technologies like Layer 2 process transactions off-chain and post-only summaries, making them faster and cheaper. ZKP's zero-knowledge proofs prove validity without revealing transaction details, enhancing privacy. The Ethereum isn't perfect, but it was a vital starting point for decentralized applications. To understand Ethereum and the EVM more deeply, we need to look at code execution, gas calculation, and contract processing, which reveals what's really happening inside the blockchain.